So what are we going to do? We're going to learn how in the world on some of those previous reactions did I know that the products were aqueous, or how did I know they were a liquid or a solid or a gas? This is what we're going to be learning for the next couple of days. These are called precipitation reactions. So in a precipitation reaction, two soluble ionic compounds, so two solutions, two aqueous solutions, are reacted together, and a solid, liquid, or gas product forms. So the precipitate can be solid, liquid, or gas, and it's going to be called a precipitate. Generally, precipitate, the actual word, is reserved for the solid. However, we're going to consider a reaction to occur if a solid, a liquid, or a gas occurs. So let's see how this happens. The precipitate forms from the net removal of ions from solution. So we spent last Tuesday working with these three different equations. We know what the net ionic equation is. We're removing the spectator ions. And so in our precipitation reaction, what we're going to do is we're going to have the final equation, that net ionic equation that showed what formed the precipitate, what formed the solid. That's removing those ions from the solution. So this is actually what happens. Here we have two solutions mixing. You can see a solution is being poured into this bottom test tube, and you can see that cloudiness is starting to happen. There are crystals forming, which means that we're removing those ions from the solution. So this is definitely going to be considered a precipitate reaction. You're going to see a lot of these in lab. So be aware that if you pour two liquids together and you get a solid, that is definitely a precipitate reaction. In some cases, it is possible to obtain more than one precipitate. So if you won't always get one type like we have here, you'll get 2, 3, or 4 types of precipitate. So we're going to learn how to perform these reactions. Now, in order to predict if something is a solid, liquid, or gas, or in this case a solid, we have very specific rules that we're going to abide by. So I want to show you those, and then we'll work with them on during tomorrow's lecture. The first rule. There's going to be 5 different rules that we're going to use to determine solubility. If something is considered soluble, it means that on the product side it's going to have an AQ. What that means is it's not going to be a precipitate. So all salts of nitrates are soluble. That means if we have sodium nitrate, it falls apart. If we have calcium nitrate, it falls apart. Anything with a nitrate is going to fall apart. That's our first rule. All salts of sodium, potassium, and ammonium are soluble. If we have sodium chloride, potassium iodide, ammonium nitride, all of those are going to fall apart. Those are soluble as well. Salts of chloride, bromide, and iodide. Okay, these are your halogens. They're going to fall apart except for silver, lead 2, and mercury 1. So this except is a very important aspect of this solubility rule. It will tell you which cations are going to form a product, which cations are going to form a precipitate. So all salts of chloride, bromide, and iodide are soluble except for these 3. All salts of sulfates are soluble, so anything with a sulfate is going to fall apart and be aqueous except for barium, strontium, lead 2, and mercury 1. You can see that lead 2 and mercury 1 are found in both of these. They tend to form precipitates when they're in a solution. And then the last one, anything else for this class is going to be considered insoluble. This insoluble means that it's going to become a precipitate. So if it's not one of these 4, it's going to be solid at the end of the reaction. So we'll work with these tomorrow. We'll work a lot of problems with these tomorrow. You're going to become very good at remembering these rules. However, I will be giving you the solubility rules on every quiz and every exam from here on out, including the final. I don't need you guys to memorize this, so you will be given these rules, exactly these rules, on every quiz, exam from here on out. And with that, that is all I want to say for this video. So have a great night, and I will see you all in class tomorrow.